In this discussion video, we'll do some practice problems involving recognizing a limit as a derivative. So I want to recall first that there are two forms for the definition of a derivative. One involves the limit as h goes to 0, one involves the limit as x goes to a. I want to first have you do a quick pause, a 1-minute pause, and see if you can write down those definitions without referring back to your notes or our videos. 4, 3, 2, 1, quick pause for a minute, try to write those in. Alrighty, so hopefully you did that. Let me just write them in now. Alright, so here are those two limit definitions. Okay, so hopefully what you wrote down is either this or close to it. Okay, so sometimes when we evaluate limits, the limits that we're doing have this form, either the first form or the second form. And when they do, this means they are derivatives. In disguise. So later, we're going to learn some shortcuts for evaluating derivatives. So once we talk about those shortcuts, and we'll start to do that in section 3.1, when we see a limit, and if we recognize, oh, that limit is a definition of a derivative, I can evaluate that limit by just finding the derivative using a shortcut, and we'll learn those slowly over time. Okay, but we are ready to actually practice recognizing certain limits as derivatives. So from worksheet, this should actually say worksheet 5. From worksheet 5, we're going to look at problem 6b. And 6b has this limit as x approaches root 3 of tangent inverse of x minus pi over 3 over x minus root 3. And the question in the worksheet has some words. It gives us some instructions. It says this is f prime of a for some function f of x at some number x equals a. Find f of x and a. Alright, so I want to begin this problem by giving you 3 minutes to try it. So 4, 3, 2, 1, pause it and try it for 3 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. Okay, so first what I want to do is match which form it seems closest to. And out of the two, I would say it looks closer to form 2 because I have x approaching some number. It's not like x is going to 0 or h is going to 0. So this looks like form 2. So what I'm going to do is I'm going to write this limit. I'm going to copy it down. The limit as x approaches root 3 of tangent inverse of x minus pi over 3 over x minus root 3. And I'm going to set it equal to that general formula, which is the limit as x approaches a of f of x minus f of a over x minus a. And now let's just match some of these parts. Okay, so I can see that x is approaching root 3, and in the general formula, x is approaching a. So that seems to suggest that a should just be root 3. And I could see that in another place as well. On the denominator, I should have x minus a. And in my limit, I have x minus root 3. So those collectively are suggesting that a should just be root 3. Okay, and then what about my function f of x? Well, f of x in the general formula matches up with where tangent inverse of x is in this numerator. And that is exactly what f of x equals. It'll be equal to tangent inverse of x. Okay, and it'll turn out that this is our answer. But maybe before I box it, there's one other thing I should check. I should check that f of a matches this pi over 3. Because if it doesn't, this is actually not a definition of a derivative. So I should check, well, what is f of a going to be? That'll be tangent inverse of root 3. And I need that to be equal to pi over 3. And I'm going to leave that as an exercise for you. It's a good inverse trig problem. It'll turn out it's true. It'll turn out it is true, so that means this is our function, and that is our value of a. What that means is this limit in this problem is just the derivative of tangent inverse of x, evaluated at root 3. And right now, we don't have a good way to find the derivative of tangent inverse of x, but we'll learn how to do that in the next chapter. And that'll give us a really quick way to evaluate this limit. All right, so let's look at another example. This one has the limit as h approaches 0 of the root of 3 times 5 plus h in parentheses plus 1. Outside the root, I have this minus 4 all over h. This is f prime of a for some function f of x at some number a, x equals a. Again, I want to find f of x and a. So I want to begin by giving you 4 minutes to try this. 4, 3, 2, 1. Pause the video, then try this for 4 minutes on your own first. All right, so hopefully you did that. Hopefully you paused it and tried it for 4 minutes. Let's talk about it together. So this limit looks like our other form. It looks like f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. It looks like that form. All right, so the first thing that I'm going to do is, the problem tells me that I actually want to find f prime evaluated at some number a. So instead of leaving the x here, I'm going to replace all the x's with an a. So if I do that, I'll get f of a here, and then f of a plus h, and f prime of a. And now let's start to match pieces from our limit to this general form. Okay, so on the numerator, the f of a plus h seems to match up with this square root of something something. Okay, so if I write that down, the f of a plus h seems to be equal to that square root thing. Square root of 3 times 5 plus h, and then plus 1. Okay, so f of a plus h means take a plus h and plug that into some function. And if I look at the square root, I do see something plus h in here. I see that 5 plus h. So maybe this is my a plus h. If that was the a plus h, what is that thing, this 5 plus h, getting plugged into? Because that'll tell me my function. This is getting plugged into the square root of 3 times x plus 1. Because if I plug in 5 plus h for the x, I get this thing over here. Okay, so at this point, this is our function. That's our f of x. And our value of a is 5. So let's write those down. F of x equals root 3x plus 1, and our value of a is 5. All right. So these questions can be tricky, especially the first time that you see them. So definitely pause the video, go through it at your own pace. And if you have questions, make a note of them and come ask using our resources for help in office hours and in tutoring.